All right, sorry about the interruption. That was a phone call from the school that interrupted my iPad, of all things. So we're looking at this one. As we said, we got these two lines, R and S, cut by transversal T. And they want us to figure out, what do you got to do to make the two things, to know that the two lines are parallel. And either alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles like 6 and 8 are congruent, or 7 and 5 are congruent, and so on. Or consecutive interiors like 9 and 5, or 10 and 6, or supplementary. Those are the things you're looking for. So here they first tell us that angles 8 and 3 are congruent. I'm just going to put a little check mark, 8 and 3. There is no known relationship between 8 and 3. They're both exterior, right? They're exterior, they're outside, but they're not alternate exterior, so that does not help me at all. Next we have 8 and 6, and so we have 8 and 6, and it says they add up to 180. That may be true that they add up to 180, but that doesn't mean the two lines are parallel. If they'd have been consecutive interiors, but they're corresponding, and correspondings have to be congruent. Now, if they were both 90, they'd be congruent, but we don't know that just because they add up to 180. The next one is that angles 8 and 6 are congruent. So this is 8 and this is 6, and those are, as we said, corresponding. They're corresponding, and if they're congruent, then that's the answer, and the answer is C. I will go ahead and put this last one up here, because a lot of people mess this one up. So they say 8 and 9 are congruent. Well, of course 8 and 9 are congruent. They are vertical angles. They're always congruent, and it has nothing to do with the S line. But it's a trick question, because you're like, yeah, they are, and they are. But it just doesn't prove anything. So, not the answer. Type your answers in the box. Those are always tougher. You can see some other class had 17%, because it's always tougher when you just have to type it in. And you have to be careful, because it says to the nearest hundredth. So when you do your work, don't be rounding to some other thing. Round to the nearest hundredth. And they want to know the distance between these 2 points. Now, I'm just going to mark those. So 5, 1 and 6, 8. Those are our 2 points. And they want to know the distance. How far is it from here to here? That's what they're looking for. Well, we could use the distance formula. We learned about the distance formula. We could use the distance formula. The distance formula is great. But we can also use Pythagorean theorem, where we complete a right triangle here using a horizontal and a vertical. And we know that's going to be a right triangle. And so we have a short leg of 1, another leg of 7, and the hypotenuse, which is what we're actually looking for here. So it's Pythagorean theorem. So we think about Pythagorean, c squared is equal to a squared plus b squared, where, as we said, one leg, the short leg, is 1, so 1 squared, and the other leg is 7, so 7 squared is 49. So c squared is equal to 50, which means c is equal to the square root of 50. So you put that in your calculator, and it's going to be 7 point whatever, 7.07, I think, or something. Anyway, but you got to round to the nearest hundredth, and so that's what you would need to do. Okay? So we have a picture, another low number for some previous class. It says, which equation is parallel to line K? Well, how would you know parallel if you looked at it? I mean, how do you know how do you know? How do you know? Well, you got to remember one big key important fact. People always think parallel lines that don't cross. True, that's elementary version. Our version in high school geometry is parallel lines are lines that have the same slope. So what you're going to be looking for is one of these lines to have the slope of this line. So the first thing I would do is look at what the slope of this line is. So I'm seeing here and here and here. Those look like points of intersection at an integral point. So I can see I want to rise 1, 2, 3, run 1, 2, rise 3, run 2. Slope is rise 3, run 2. Slope is 3/2. And it's a positive. We can see that it's a positive. So the slope is 3/2. That's our thing. So that's what I'm looking for. The problem with all three of these is you can't see the slope by looking at the line. Why? They're not in the right form. They're in standard form, not in slope-intercept form. So it would be really, really nice if those were all solved for y, and they are not. So the first thing you'd have to do is solve each of them for y, and then see who has the correct slope. the right answer, I believe, is A. Let's take the A and see if I'm right. 3x minus 2y equal 10. If I'm going to solve for y, I'm going to kick the 3x over because I know what I want. I want it to be in this form, y equal mx plus b. So that's why I'm solving for y. So I kick the 3x over by subtraction, and then I divide by the -2. When I divide by -2 here, divide by -2 here, and divide by -2 here. And so the equation of this line, written in slope-intercept form, gives us a slope of 3/2, which is what we were looking for, and that's the answer. If it hadn't been the first one, I would need to do the others. If I was taking a really important test, I might do all 4 of them anyway, just to make sure I didn't mislook or misfigure. What are the maximum number of lines of symmetry a square has? Lines of symmetry are usually horizontal, vertical, and diagonal. And so a line of symmetry means you can fold it on that line, and everything on one side of the line will touch everything on the other side of the line and cover completely. So you can see there's one this way, and there's one this way. Those are the horizontal and vertical options. But I believe you can also draw one diagonal, and that would do that, and that way it would be answer C. The maximum number of lines of symmetry of a square is 4. I'm gonna leave this question to another time, and I'm gonna post a link for you to watch some things online that will be helpful as far as drawing segments and doing, actually this one is pretty easy. So the segment congruent to AB, and then it got some AQ, APs and all that. So I just took my compass and put it here and put it here, and then drew an arc, and so you can see that AT will be congruent to AB. But I was saying I'm going to post a website that you need to look at for some of these constructions like this one. That would have been helpful if we had to do this or these constructions. And there are about 4 that are very common and that we would need to do in order to be really proficient at the things that are required. All right, back to easier stuff, because construction can be a little difficult, and that's why you need to look at their website and do some practice. Triangle XYZ, the angles have the following measures. So we have this triangle, XYZ, you got these, and they ask you about the sides. And they ask from longest to shortest. Well, the first thing I would do is draw a triangle, XYZ. Is that drawn to scale? No. Did I try? No, I'm not going to try. But I do know that this angle here is 40, according to what they told me, and this one is 60, and this one is 80. It may not be in my picture, I don't care. But I do know this is the longest side because it's across the road from the largest angle. And this is the shortest side because it's across the road from the smallest angle. And so this is Goldilocks here in the middle. So when we're looking at this from longest to shortest, longest is XY, and you can see that C and D both say that. Shortest is YZ, and so the answer is D, with Goldilocks in the middle. Don't be afraid to draw. Draw pictures. Label things. Which statement is not true for this triangle? And this has to do with exactly what we just did, except it's presented differently. They want to know which one is not true. Okay, I can tell you before we look at all this stuff here that that one's longer than that one, and that one's longer than, so that's the sides. But think about the angles, because that's what this is asking us about, is all the angles. So who's the smallest? This is the smallest one. Who's the largest? This is the largest one. And this is the Goldilocks angle because it's across the road from the Goldilocks side. So you look at it, it says E is bigger than C. True, because larger is bigger than smaller. D is smaller than C. That's not true, is it? D is not smaller than C. C's the smallest. So that's the not true one, and that's what they're asking for, and that's the B answer. Let me go ahead and finish this out and just say that, let me get where I can see it. E is bigger than D. Well, E is bigger than all of them. It's the largest one. And then C is smaller than E, and it's smaller than all of them because it's the smallest one. So yeah, it's answer B. You just got to take your time with those. And of course, you got to kind of see through what, the veil of what the question is as well. Which of the following could not be the lengths of the sides of a triangle? Now we get these confused sometimes because here they're asking about the length of the side of a triangle, and one of our first thoughts is it's a right triangle. They didn't say anything about a right triangle, so it's not that. This has to do with the fact that the two short sides have to be longer than the third side. You have to be able to add the two short sides to be longer than the third side. That's how you know it could potentially be a triangle, not necessarily a right triangle, just a triangle. And so you can see the two short sides here do not make enough to be 15. So this is not a triangle. The two short sides here are longer than the 5, so that one's okay. And the two short ones here are longer than the 20, so that one's okay, it's a triangle. And these two here, obviously longer than the third side, it's an equilateral triangle. And so the not is the A. Is the A. Sandra needs to create a triangular structure for her science project. She has 2 pieces of bamboo measuring 6.5 inches and 8.1 inches. How long must her third piece of bamboo be in order to create a triangle? This is really the concept of the previous question. It's just presented differently. And so what we're seeing is we've got 2 known sides, and we want to know what's the potential for the third side. And so the way we looked at that was we said, we did a couple of things. We did this with a 6.5, an 8.1, and a blank. But really what we were doing is saying that X is going to be squeezed in between these 2 numbers. X being the unknown side, the third piece. And how do we find these 2 numbers here? Remember, there's not an equal here. It's just less than, less than. How do we find these 2 numbers here? We subtract, and I believe that's 1.6, and we add, and I believe that's 14.6. So the potential is it has to be between here and here. Now we talk about that a lot in class because the 2 short ones had to be longer than the long one, or in this case, the 2 short ones had to be longer than the long one. And so that's why it can't be equal to 1.6, it can't be equal to 14.6, but it can be anything in between. So when you look at these over here, you can see they put that answer, which is this, they put that answer, which is this, and the correct answer is B, because it's in between those 2 numbers. So how do you find those 2 numbers? You subtract and you add. That's your range. It can't be the actual number of subtraction and the actual number of addition, but it can be anything in between the 2. I'm going to skip that one for now. The triangles below, in the triangles below, what value of X would make the triangles similar? Triangles similar. We can see here that we've got these 2 triangles that kind of look similar. Remember, similar triangles have triangles that or have angles that are congruent, corresponding angles that are congruent, and corresponding sides are proportional. So we would think that 4 compared to 6 would be the same as 10 compared to X when you're looking at these 2 and these 2. So if that's the case, then 4X is equal to 60. So X is 15, making the answer A. Answer A. Little math there, little piece of something to remember, so you can see why the previous class maybe didn't do great on this one, but that's not a horrible question. Keith needs to build a bridge to go across a pond. He has been able to collect the following measurements. About how long does his bridge need to be? This is one of my favorite types of questions because, as we said in class, this is where we can find the measure of things that we haven't measured by knowing other measures and relationships. This is a right triangle where we happen to know 1 leg and 1 angle technically. We know 2 angles technically. We know all 3 angles because you know that one's 40 because those are 90 because that's 90. We know that's how that works. But the beauty of this whole problem is this is a trig problem. Sine, cosine, tangent. So when we look at sine, cosine, tangent, remember orange horses always have orange angles. So let's talk about this. In respect to this angle here, this is the adjacent leg, and they're asking us about this bridge across the pond, which is the opposite leg. So that makes this a tangent problem. You just have to bird dog that out. You just have to find it. So it's a tangent problem. So the tangent of 50 is equal to opposite divided by adjacent. Opposite is the unknown in this case, and the adjacent is 10. This is one of the easier ones as far as the calculations go. And so if I want to get x by itself, I've got to get rid of the division 10, so I multiply by 10. So 10 times the tangent of 50 degrees is equal to x. Remember, if you're using a calculator, and you probably would be, make sure you're in degree mode, because this is a 50-degree angle, and you want to be in degree, not radian mode. So you just plug that in the calculator, poof, you're going to get an answer. You're going to get an answer. I can tell you one additional thing, and that is, since this is 40, that is going to be shorter than this, because that angle is bigger. So this is going to be a larger side than that one. Ah. So if that's 10, this can't be anything except C. That's sneaky. But that's also one of those things where, you know, when you know stuff, it helps. It helps. It just does. In isosceles trapezoid, now what's an isosceles trapezoid? Well, it has one pair of sides that are parallel, and the other pair is not parallel, because if it had both pairs are parallel, it wouldn't be a trapezoid, it'd be a quadrilateral. But they tell us that WN is 6. This is 6. WK is 9. And the perimeter of the whole thing is equal to 40. And it says, what is the length of KM? What is the length of KM? Well, let me go back and say one more thing. I said what a trapezoid was, but I did not deal with the isosceles piece. If it's an isosceles trapezoid, that means the two legs are the same. So if that one's 9, this one's 9. So you can see total I've got 18 plus 6 is 24. How much do I need in all? 40. What's this side gonna be? 16. Answer is A. It's a little sneaky. You gotta watch your words. They usually give you information. You just got to be able to see it, recognize it, interpret it, know what to do with it. Using the diagram below, what is the measure of angle 1? So I'm just going to pull this out of the way. You see a little bit of all of our answers but 1. So we want to know the measure of this thing here. All right. Do you agree that angle 1 is an exterior angle, first of all? It's an exterior angle. And when we look at this figure, we can see angles 1, 2, 3, 4, 5. 5 of them. So this is a pentagon, right? It's a pentagon. What's the distance around any gon? Pentagon or any other gon? The distance around the outside is 360 degrees. When you look here, you've got 104 and 44 and 90 and 60, and then one unknown piece. How much does this give us? Well, I see 148 here. I don't have my calculator, so I'm doing this in my head, and 150 here, which makes 298, which means if I gotta have 360 in all, I got 298 out of the 4 that I know. How much is left for angle 1? 360 minus 298, 52. Answer. Maybe I can't do math. Maybe I can't do math. If you're sitting at home watching this, I hope you're seeing it. Let me do it again. 104, 44, and 90, and 60. So that's 148, and that's 150, and that's 298. It's gotta go to 360, I was going to 350, I don't know why. So it's 62, answers A. God. All right, well, hope you're laughing at home. Not really. One exterior angle of a regular polygon measures this. What is the measure of one interior angle? Well, the key question here is, what kind of gon is this? You know, how many sides are there? And so this is very similar to the previous question as far as the major piece or concept, because we're talking about exterior angles. And since it's going to be 360 all the way around, and all of them are equal because this is a regular gon, you just do, and you find out you're talking about a nonagon. There's 9 sides. And then you can find out how many degrees is in an interior angle of a nonagon. One way is to use the formula, n minus 2 times 180. Another is to do the chart or something like that. So in our case, that's 7 times 180, because 9 minus 2 is 7. And so that would not be too bad to figure out. In this circle, this is a good question. Listen, this is the kind of question that keeps you from making advanced on an SOL, for example. I like this question. It's a thinker question. And it helps that we exposed you to something like this previously anyway. In circle P, so we know that's the center. AC is a diameter. You know, it's a diameter. It goes from one side of the circle through the center to the other side of the circle. It's a diameter. They tell us that AC is perpendicular to BD. So that means this chord here passes through this diameter in such a way that it creates right angles. And they tell us that BD is 24 and that AC is 26. So I'm just going to put this little, if BD is 24, one of the things we know is that that's 12 and that's 12. In other words, we know that when a chord intersects a radius or a diameter and creates a perpendicular situation, then the diameter or the radius bisected the chord. So if that's 24 in all, it's 12 and 12. They also tell me that AC is 26. Now AC is this whole thing right here, 26. The diameter is 26, which means a radius is 13. Do you agree? Radius is 13. Now I'm going to use that piece of information and I'm going to draw in another radius right here and label it 13. Now why did I do that? Well, I'm out in front. I realize that. I should have done this first. What is the length of PE? PE is this little piece right here. That's what they want to know. How far is it from this point of intersection of the chord and the radius and the center? Well, it just happens that what I did here with drawing this radius is I created a right triangle. And I created a right triangle where I know one leg and the hypotenuse looking for the other leg. So that's Pythagorean theorem, da-da-da-da-da, and ta-da. Find the arc length of arc AB when the diameter of the circle is 10 inches. So I'm just going to go ahead and mark that. The diameter is 10 inches, so this is 5 inches. You agree? If the diameter is 10, the radius is 5. Okay, so let's talk about this. Arc length. There's a formula that we had for arc length where we said the arc length is part of the whole thing. Circumference, the whole circumference. What they want to know is how far is it from here to here? Like how long is that piece? You know, if you're putting a piece of string or a piece of fencing or whatever, how long would that piece be? It's a pie crust, whatever. How long would that piece be? And so it's part of the whole thing. Part, because it's 360 degrees all the way around. And the whole thing is the circumference, because we know part of this outer area, which is called the circumference. So for us in this case, the degree measure is 100. So you have 100 divided by 360. And circumference. Circumference for us is either pi d or, 2 pi r. That's what circumference is. I'm going to go ahead and use the 2 pi r, where the radius is 5, because I had found the radius was 5, but you could use the diameter 10, and the 2 times the 5 is still 10. And then you just put that in the calculator and do it, except, I see something else here. All the answers have pi in them, look at them. All the answers have pi in them. So I'm gonna not put that in the calculator, I'm just gonna put that in the calculator. And then reduce it to lowest terms with the pi still in the answer. So what's that? If it's still in the answer, don't put it in the calculator. This question here, I'm not gonna take the time to do all of this. I'm just gonna say Becky is making a necklace for a friend. She is going to paint each bead on the necklace. How much paint will Becky need? What do they wanna do? Where do you put the paint if Becky's painting a necklace? Where do you put the paint? You put it on the pieces, right? You paint the pieces. That's called surface area. Surface area. And there's no shortcut to this. You're gonna have to do surface area for 1, 2, 3 pieces. You're gonna have to do surface area for this, which is a rectangular prism, this, which is a cylinder, and this, which would appear to be a sphere. So you got these 3 things you have to do, surface area for each one of them. Watch your measures. Be sure you note that here in this case the radius is 2, and in this case the radius is 2. Yeah. So you do each of those independently and then add them together to find the total surface area for Becky to paint, and then you'll be able to see that's how much paint she needs to cover that much surface area. I did a video for you a few weeks ago on this. I'm just going to copy this down. I hate it when it's in 2 lines like that. So I'm going to put it all in 1 line so that we can see it easier. But I did a video where I talked to you about the diameter or the equations of circles. And in this case, they want to know what is the length of the diameter. Well, hopefully you remember that this is in the form of x minus h squared plus y minus k squared equal r squared. Okay, so I'm going to say something that is not relevant to this question, but it could be relevant to a question you'd see in the future. And that is that the center of this circle, let's call it C, the center of this circle is at 5, -4. Now that's not this question, it's nothing to do with this question, but I just want you to see that's how that would work. Remember, it's opposite sign, this is how it works. And then the radius, since this is r squared, radius is 12. Now that's not the answer to the question, although it is one of the answers to the question, because they didn't ask you for the radius, they asked you for the diameter, so you can see where you can get yourself in trouble there. So if the radius is 12, the diameter is 24. Answer D. And the last question, the volume for boys basketball is, Dan would like to get a ball with half the volume for his son. What is B the diameter? Wow, that's great writing right there. What is B the diameter of the ball that Dan will buy for his son? What is B? I don't know. If he wants it to have half the volume of this, then you're going to take the 434 and divide it by 2 and find out the volume of the ball that Dan wants for his kid. Then you take the formula for finding volume and work backwards. Work backwards and find out what the radius would be, because the formula is going to have radius, going to have r, and then double that for the diameter. That's it.